everyone, I'm Anthony and this is the Biotech Brief, where I give you short and simplified updates about the biotech industry. This brief, I'll tell you about recent efforts to use human DNA for digital data storage. In case you aren't familiar with this topic, basically researchers and companies have been experimenting with using human DNA as a storage device, and they've been doing these experiments for a few key reasons. For one thing, data can be packed into DNA way more densely than it can be packed into electronic technology. To give you an idea of how much more compact and efficient DNA is at storing data than modern data centers, experts estimate that if you were to fill a shoebox with DNA, it would hold the equivalent of about 100 giant data centers worth of data. Secondly, electronic storage devices just aren't improving fast enough to handle all the data we're producing anymore. DNA is also really durable when it's kept cool and dry, as evidenced by the fact that researchers have been able to reconstruct much of the genome of ancient humans using 400,000-year-old bones they found in a cave in Spain. In contrast, the magnetic tape that is the best long-term data storage option today starts to fall apart after only a few decades. In order to store data in DNA, it has to be translated from the zeros and ones of computer language into the base pairs that DNA uses to store our genetic information. And that brings us to the biggest problem with this method of storing data: it's still pretty expensive. Despite the cost, companies like Microsoft are still very active in this space. In fact, Microsoft recently reported that it had written 200 megabytes of data into DNA. That's the equivalent of about 1,000 emails without attachments. Now, researchers had already shown that you could write data in DNA, but this was a big deal because no one had ever put that much data into DNA all at once before. All of this is important because if prices for reading and writing DNA continue to fall, DNA should continue to become a more realistic option for storing data. The only problem I see is people lose their little jump drives all the time, and DNA is a lot smaller, so I could see people misplacing their DNA jump drives pretty easily. In all seriousness, this is one of my favorite topics in biotech, so I'll be sure to let you know if there are any updates or advances. In the meantime, make sure you subscribe to the Biotech Brief on YouTube, and I'll see you next time.